Being able to slice an array into smaller pieces and only work with a portion of the larger array can be beneficial in many cases. In more complex situations, you may work with buffers, or for example, have large byte arrays where you know the fixed positions that you want to slice off. In these situations, if you were to slice that as a normal array, you'd get new arrays and copies of values or references depending on the content of the array. This can lead to an unnecessary number of allocations and a larger memory footprint. There's a bit of help in .NET that allows for a more memory-efficient approach. We can introduce a generic type called span of t. The definition of a span is that it provides a type and memory-safe representation of a contiguous region of arbitrary memory. The span of t supports an implicit conversion from array of t, which means that if we change the variable type to span of t, this could be used as a span instead. This implicit conversion will give you an instance of a span of t. It doesn't require much computational power or additional memory to do this. The implicit conversion is the same as constructing a new span of t and pass the array to the constructor. This will give you an object that spans the entire array. Internally, the constructor only stores a reference to the array and doesn't create a copy of it. You could easily validate this by modifying an element in the span after you've created a span that represents the array of data. If you do, the elements in the array and the span will be identical. This proves that it in fact points to the array and didn't make a copy. Not only can the span be used to reference an array, but it can also be used to work with unmanaged memory. This makes it very useful and a powerful tool. If we use a data structure that implements IEnumerable of t, such as list of t, this would have to be converted into an array before it can be used as a span. It's wise to only do this conversion once, and then use a local representation of this span throughout the entire method. The span is stored on the stack, and there are some specific situations where the span cannot be used, such as in asynchronous methods and fields in your classes. The span comes with built-in support for creating a representation of a slice. This requires minimal processing power and really just lets you point to the different elements in the span. It doesn't have to copy the entire slice of that array. This is extremely important. Not only is it more performant, but it also comes with greater responsibility. If you were to change the value in the slice, that would also change the value in the span that this was sliced off. The beauty of this is that we can request multiple different slices from the same span, and it wouldn't require much in terms of memory or processing power to do so. A good example of where this is truly useful, if you work with a large byte array, and you know that certain ranges of elements throughout this array represents important pieces. You can grab those slices without having to copy each portion. What about if we want to pass a span around, to have other methods in the application work with the data and leverage the power of that being a span? from what we've discussed so far, this would greatly improve performance throughout the entire application, especially if we can avoid unnecessary allocations. The span is a ref struct, which is stored on the stack, and this alone comes with a few limitations. The compiler will tell you if you use a span or any other ref struct incorrectly. We can use a span of t as a parameter to a method, as long as it's not an asynchronous method. If the method signature defines that you want a span of t, and you pass an array, it would be implicitly converted to a span. Using spans makes it extremely memory efficient, especially if we need to use slicing throughout the methods. You can use the range syntax with the span, just like we saw before. The only difference is that it's much more efficient, because it's simply pointing to 2 positions in that original array. This will result in a span over the array.